Solving inequalities. A closed interval is denoted with brackets. Consists of real numbers x for which a is less than or equal to b. The open interval is going to be denoted with parentheses. The only difference here is a and b, those endpoints are not included. So with closed intervals, we have equality. With open intervals, we have strict inequalities. Let's graph the set on a number line and then express the set in interval notation. For x is less than or equal to 4. Imagine a number line, and we're focusing on the point 4. Since we have equality in our symbol, we can include the 4, meaning we can close in the circle on the 4. And then we want to shade. X is less than 4, so we're going to shade everything less than 4. Everything to the left of 4. That's the graph. To write the interval, we're going to start with negative infinity, parenthesis on negative infinity, and put a comma, and then we go up to 4, and we'll put a bracket on the 4 because we can include the 4. In the next example, notice we have two distinct endpoints. So on our graph, we have -1 open, and then we're going up to 5, and we're including the 5. And if we wanted an interval, the interval would be from -1 open to 5 closed. -1 we leave open because we have a strict inequality. 5 we have equal to, so we bracket the 5. In the next example, we want to know how to get from this inequality to the inequality on the right side. So how do we get from x to -3x and from -3 to 9? It looks like we're multiplying both sides by -3. When you multiply or divide by a negative, that's going to change the direction of the inequality. So we just switch directions of the inequality. In the next example, we're going from x is greater than 4 to x plus 3 is blank 7. It looks like we're adding 3 to both sides of our inequality. And doing that will not change the direction of the inequality. So we stay greater than. The only time we're going to flip the direction of the inequality is if we divide or multiply by a negative. So the steps to solve an inequality are the same as the steps to solve a linear equation. Step 1 is to simplify both sides as much as possible. Again, simplify means to remove parentheses and combine like terms. Step 2 is put the variables on one side and constants on the other. And then that final step is to divide to isolate the x. And just be careful. If you divide or multiply by a negative, make sure we switch the direction of the inequality. The first thing we'll do is distribute the 2 on the right side. 7x plus 15 is greater than or equal to 10x plus 8 minus 3. Combine like terms on the right side. 7x plus 15 is greater than or equal to 10x plus 5. Now we want to put all the x's on one side and the constants on the other. It doesn't matter which side you put x on. I prefer to put x on the left. Next, we'll subtract 10x on both sides. And subtract 15 on both sides. Negative 3x is greater than or equal to negative 10. Finally, divide by negative 3. And notice when we divide by a negative, we change the direction of the inequality. X is less than or equal to 10/3. From here, we'll represent this as a graph. So close circle, since we have equality, denote that point as 10/3, and we want it to be less than 10/3, less than or equal to 10/3. If you start with the graph, the interval notation will be a little bit easier. Notice on the left of the graph, we're going to negative infinity. On the right of the graph, we're going up to 10/3, and we're including it, so we denote it with a bracket. In this example, it may be best to eliminate the fractions first so we can multiply by the LCD, which in this case is 6. Multiply every term by 6. Here we can cancel some things. 3 goes into 6 twice, and here the 6's cancel. We're left with 2x is greater than 12 plus x. Subtract x on both sides, and x is greater than 12. From here we can graph. Open circle on the 12, and we're shading to the right because we want x to be greater than 12. And that makes the interval notation a little bit easier. On the left we have an open parenthesis on 12, and we go to positive infinity, open parenthesis. Next, we'll look at compound inequalities. The steps are isolate the variable in the center. Any operations to isolate the variable in the center must be done in all 3 areas, the left, the middle, and the right. In our first example, we will multiply everything by 2. So the left, the middle, and the right side. We get 0 is less than 3x plus 2 is less than or equal to 8. Now, our goal is still to isolate the x in the middle, so we subtract 2. Make sure you do it on the left, the middle, and the right. Negative 2 is less than 3x is less than or equal to 6. Finally, to isolate the x, we need to divide everything by 3. We get negative 2/3 is less than x is less than or equal to 2. Let's graph this. Notice we have 2 distinct endpoints this time. Open circle on the negative 2/3, and then we go up to and include the positive 2. If you sketch a quick graph, that makes the interval notation a little bit easier. On the left, we have an open parenthesis for the negative 2/3. We're not including it. Then we go up to and including the positive 2. So bracket on the 2. Next, we want to isolate the x in the middle. If it helps you, multiply everything by 3. So we get negative 3 is less than or equal to 3 minus x less than 3. To isolate the x now, we need to move the 3 that's in the middle, so we'll subtract it everywhere, left, middle, and the right. Negative 6 is less than or equal to negative x is less than 0. Now to get x by itself, we need to divide by negative 1. And again, if you do it in the middle, we need to do it on the left and the right side as well. 6 is greater than or equal to x, which is greater than 0. Remember, if you divide or multiply by a negative, we need to change the direction of the inequality symbols. Now, this may look a little weird to you since the numbers are going down. Let's reorder this. Think of it as a number line. You want the smaller numbers on the left. So if we reorder this, we'll have 0 is less than x is less than or equal to 6. And now the numbers make a little more sense since the smaller numbers are on the left, bigger numbers are on the right. Let's graph this. 0 is not included, so we'll leave it as an open circle. We go up to 6 and close it in. We are including the 6. 0 to 6, and we include the 6. Absolute value inequalities. Graph the solution sets for the following inequalities, and then write the solutions as an inequality without absolute value bars. So think of a number line and think about what absolute value actually means. Absolute value means distance from 0. So in this first example, we want our distance from 0 to be greater than 4. So where does that happen? We have two places where the distance is 4. So the distance from 0 here is 4. The distance from 0 on the left is also 4. But we want our distance from 0, that absolute value, to be greater than 4. So we actually want this region here that is bigger than 4. And we also want this region here that is bigger than 4. So we're actually looking for x to be less than negative 4 and for x to be greater than positive 4. In the next example, we have the absolute value of x is less than 4. Again, let's look at that on a number line. So 0 is in the middle. We have negative 4 and positive 4. We want the distance from 0 to be less than 4. So this time, we're looking at everything between negative 4 and positive 4, because we want that distance from 0 to be less than 4. So when you're dealing with absolute value inequalities, there's going to be two situations that could occur. Case 1 is when we have two distinct intervals, and case 2 is when we have a compound inequality, where the intervals are pointing towards each other, and our interval is between 2 points. Case 1 is when the intervals are pointing away from each other and you have two distinct intervals. So let's solve this absolute value inequality and express the answer in interval notation. The first thing you want to do is isolate the absolute value bars. In this case, that's already done for us. So the next thing we're going to do is split this into two separate inequalities. The first one will copy the inside of the bars but drop the bars. Copy the right side of the inequality as well. So basically copy the problem but drop the bars. Then the second inequality, we're going to copy the inside of the bars, but then we're going to change the direction of the inequality and we're going to change the sign of that constant. We're basically just doing case 1 here. Just like we did here. We have two separate inequalities pointing in opposite directions. Now we just solve each of those independently. On the left, subtract 1. And then divide by 2. And on the right, subtract 1 and divide by 2. The next thing we'll do is sketch this to help us set up our interval notation. So 2 is filled in and going to the right. X is greater than 2. And then negative 3 is over here. Negative 3 filled in. We are including negative 3 and we're going to the right. So we have two distinct intervals here. Our interval notation is negative infinity up to negative 3, including the 3, union 2 to infinity. And again, we're including the 2 here. This is our interval notation. Example B, we first want to isolate the absolute value bars. So here we need to add 4 to both sides. Once you've isolated the absolute value bars, we're going to split it into two separate inequalities. The first one is going to be basically copy the problem but drop the absolute value bars. The second one, you're going to copy the inside of the bars, and then you're going to change the direction of the sign and change the constant. Again, we're going to change the direction, change the sign. From here, solve your inequality. On the left, we need to subtract 1 on both sides, and then divide by -2. Remember, dividing by a negative changes the direction of the inequality symbol. On the right, subtract 1. -2 is greater than -4. And then divide by -2. Again, that changes the direction of the inequality symbol. So we have x is greater than -1 and x is less than 2. Let's sketch the graph. -1 is open, and to the right, x is greater than -1, and 2 is also open, but 2 is pointing to the left because x is less than -2. So we have a compound inequality here. This helps us set up our interval, which is -1 to +2. Parentheses because those are open intervals. We do not have equality. Next, we want to isolate the absolute value by adding 5 to both sides. So add 5 to both sides, and we get the absolute value is greater than or equal to 7. Once you've isolated the absolute value bars, we can split it into two inequalities. The first one, we're just going to copy what we have, drop the bars, copy everything else. The second inequality, we're going to copy the inside of the bars, drop the bars, we're going to change the direction of the inequality, and change the sign on that constant. Now solve each of these independently. On the left, we need to subtract 3. -w is greater than or equal to 4. Divide by -1. That changes the direction of the inequality. W is less than or equal to -4. On the right, we'll subtract 3. -w is less than or equal to -10. Divide by -1, and don't forget to change the direction of the inequality. W is greater than or equal to 10. W is less than -4, so we're pointing to the left of -4, including the -4, so we fill it in. 10 is including and greater than. This helps set up our interval notation. -infinity to -4, union 10 to +infinity. In our next example, we need to first isolate the absolute value, so we'll subtract 3. Absolute value of x minus 4 is less than -1. This is a special case. Think about what absolute value means. Absolute value means whatever is on the inside is a positive number. So we have a positive number that is less than a -1. That's not possible. You can't have a positive number that is smaller than -1. So here we can stop and say that this is not possible. There's no solution. Next, isolate the absolute value first. So we'll subtract 3. Subtracting 3 on both sides gives us -1 on the far right. This time that negative on the right side is okay because we have a positive number is greater than -1. So here we'll continue with our process from earlier. Split this into two inequalities. The first one is easy. We just copy everything except for the bars. The second inequality, copy the inside, change the direction of the inequality, change the sign on the constant. Add 4 to both sides. And we get these two inequalities. Let's graph them. 3 going to the right, and 5 going to the left. They meet in the middle, so our interval, 3 to 5. Open parentheses because the 3 and the 5 are not included. Sue wants to lose weight. For healthy weight loss, it is recommended that she exercise 200 to 300 minutes per week. For the first 6 days of the week, she exercised 40, 45, 0, 50, 25, and 35 minutes. How long should she exercise on the seventh day to stay within the healthy guidelines? So we have a range of healthy guidelines. We have 200 to 300. We want to stay within those boundaries. 6 days of the week, she exercised 40 plus 45 plus 0 plus 50 plus 25 plus 35. And on the 7th day, we don't know. We'll call it X. Simplify. Combine like terms in the middle. 200 is less than or equal to 195 plus X, which is less than or equal to 300. Subtract 195 on both sides. We get 5 is less than or equal to X, less than or equal to 105. And notice we've isolated X. So on the 7th day, she needs to exercise between 5 and 105 minutes if we want to stay in those guidelines.